Hi, welcome back. In this video, I'm going to start to look at a few actual examples of how to use our calculator when working with the normal distribution. So we're going to start off with this example, find the probabilities, and we are given a probability statement. Find the probability that z is less than 1.23. Every time we do one of these problems, we must draw a normal distribution. This is not optional. We need to label our axis. In this case, the variable I'm looking at is z. It is approximately normal with a mean of 0 and a standard deviation of 1. All of this is very important for setting the context of our problem. So the first thing I need to do is look at my probability statement here, and I am going to draw this on my picture. So the probability that z is less than 1.23. So a z value of 1.23, that's on my axis here. So I am going to identify 1.23, and then I'm going to look at my inequality symbol. It is less than, so I am looking for the probability that the z value is less than 1.23. So I'm looking for the area under the curve to the left of 1.23. In this case, I'm going from a z-score to an area, which means I'm going to use my normal CDF function. So I'm going to pull out my calculator here, and I'm going to do a second distribution, normal CDF, and I'm going to look for the leftmost z limit, which is negative infinity. Our calculator cannot do negative infinity, so we are going to approximate it with the largest number our calculator is capable of, which is 1e99. So instead of putting in negative infinity for the left limit of this region, we're going to put in negative 1e99. So I have that in my calculator. My upper limit, that is the upper z value, 1.23. My mean is 0, and my standard deviation is 1, and I have those in there correctly. If you don't have the updated operating system, you will get just the normal CDF printed on your screen with an open parentheses, and you will list lower, upper, mean, standard deviation in order. So this tells me that this area is 0.8907. So we could write this probability as 89.1%. You can represent it either way. Both of those would be correct answers. The probability that z is greater than 2.81. Again, we must draw our normal distribution. We're going to find 2.81. It's not very important that this is drawn perfectly to scale. It is important that we shade the correct area. So we are looking for this area here. So I'm going to go back to my calculator, and on my calculator, I'm going to pull up normal CDF. The left limit here is now 2.81. The right limit is now positive infinity, which we are going to approximate with 1e99. So 1, the E button, we hit second, and then the comma, 99. The mean is 0, the standard deviation is 1. And I get that this is 0.0025. So that is my probability. We can either have that, or we can say it is 0.2%. Both of those are correct. You do want to make sure that with your answer, you connect that value to the region you've shaded. So we want to have that area with it shaded. We want to distinguish between z's and areas. Z's are the x-axis. Probabilities or areas are the shaded part under the curve. Now, this question down here would have been a little bit trickier with a table. We would have needed to find the area to the left of this, the area to the left of this, and then subtracted them. Much more straightforward and simple here. So we are going to draw negative 1.43, and we are going to draw 2.05, and we are going to shade. So we're looking for that area. Again, on my calculator, very simple. Pull up normal CDF, negative 1.43, 2.05, mean 0, standard deviation 1. Hit enter. And this is 0.9035. So this is 90.3%. So you can see how the calculator really sped this work up and made it a lot faster. But that was great. These were z-scores. These wouldn't have been very difficult to do by hand with our table. So let's look at something that would be a little bit trickier. The national average ACT score is 20.8 with a standard deviation of 4.8. Find the probability that a student scores between 24 and 26. First thing I want to do is define my x variable. So in this case, x is a student score on the ACT. And I know that the mean is 20.8 and the standard deviation is 4.8. And let's say that this is a normal model. ACT scores are normally distributed. That is how they come up with what your score actually is. So this is a normal distribution with the given parameters here, and this is my variable x. So I am going to draw a normal distribution. When I draw a normal distribution, sometimes they'll be pretty, sometimes they won't be. It doesn't really matter. They just need to look somewhat like this. The important things that you must include in your drawing: the curve, the axis. You need to mark the mean on your axis, and you need to label with the name of the variable. So we've defined x. So x is approximately normal, and in here we must include the mean and the standard deviation. So we've fully labeled this as of now. I want the scores between 24 and 26. So I want what percent of students score in this range, or what is the probability. So I want that. I'm going to label this with a probability statement. So that means I'm going to write probability of, and I'm going to write an inequality statement involving my variable x. So that will be 24 is less than x is less than 26. It doesn't really matter if these are less than or equal to. We'll get to that a little later. Okay, now, if I were to do this using a table, I would need to convert my x's into z's. So I would need to do this calculation for 24 and for 26. Then I would need to go to my table and I would need to subtract. That sounds like a lot of work. Here's how amazing it is with your calculator. I am going to go to normal CDF. I'm going to put in the left limit, which is 24. The right limit, which is 26. The mean, which is 20.8. And the standard deviation, which is 4.8. It does all of the conversion for you. It does the calculation. And this is 0.1132. This is exactly what you would get if you did all of the conversion and calculated by hand. So what we can say here is the probability that a student scores between 24 and 26 is 11.3%. It's really important that we get in the habit of translating our math into language that people understand. People don't like this. It's confusing, it's intimidating, so let's get in the habit of putting it into a sentence that makes sense to general people. In the next video, we're going to look at going from area to z-score or x value.